The first question that we're going to solve in this master series is this one over here. This is from May-June 2010, paper 12, question 3. Let me just check one thing. And it says, the functions f and g are defined for any x that is real by, and you have here x equals 4x minus 2x squared, and g 5x plus 3. So a parabola and a straight line. Find the range of f, and then find the value of the constant k for which the equation g of f of x equals k has equal roots. All right, so let's look over here at the question. Here it is. You want to know the minimum value, no, the range of f. And the range of f in a parabola is given by what? Is given by the limit of it is going to be the y-coordinate of the vertex. And then the range is either going to be any value of y above that or below that, depending on what? Depending on the coefficient of the term in x squared. Okay, in this case, the coefficient of the term in x squared is negative, is -2. So this is an upside down parabola. So this means that the maximum value of y, the y-coordinate of the vertex, is going to be its maximum point. All other values of y are going to be below that. So to find the vertex, we'll just put this in a completed square form, all right? I arranged this so I have the term in x squared first. Okay, so I factorize -2 over here, so I have x squared plus 2x. Then I open brackets and I write x. Then I put half of this, so -2 over 2, that's -1. Close brackets, square it. Then I'll do -1 squared, that's 1. Remove it. Close brackets, expand the brackets, the main brackets, and here I have the expression in a completed square form. So now I can take the coordinates of the vertex, the negative of this and that, so 1, 2. So I know that the range is going to be y smaller or equal to 2. Again, upside down parabola, the y-coordinate of the vertex will give you the maximum value of the range. Then you have for question 2, you have the composite function g of f of x equals k, and you know that you want to get the values of k, the value of values of k for which there are 2 equal roots to this equation. So first of all, get the composite function g of f of x. So what is g? G is 5x plus 3, but instead of x, you now have f of x, which is this stuff. So you're going to write 4x minus 2x squared, where you used to have x. And now expand, and you have this expression. Now equal this to k, which is the same thing as bringing k to this side and equaling it to 0. And you want this parabola to have 2 equal roots. So you should know by now that in order for you to solve these types of questions, you have to look at the discriminant for 2 equal roots. The discriminant needs to be 0. Okay, 2 equal roots actually means just 1 root. Okay, putting things in simple terms. So that's the discriminant equaling to 0. So equal this expression to 0. Okay. What is this expression? The discriminant, so b squared minus 4ac. b is 20 minus 4 times a, which is minus 10. Sorry, I should be looking at this one. So b, which is 20, minus 4 times a, which is minus 10, times c, which is 3 minus k, equals 0. Now you have to solve this, and you have the value of k equals 13. Okay, next question is this one over here. Yeah, the function x equals x squared minus 4x plus k is defined for the domain x bigger or equal to p, where k and p are constants. Express the function in this form of completed square, in this completed square form, where a and b are constants. Okay, we'll go one by one. So let's do that. This is as simple as looking at the equation. Okay, and doing the normal process. So you open brackets, write x, then put half of that, so that will be -2. Then square this and remove it. -2 squared is 4, so you have to remove it. -4 plus k. So you already have in the form that you wanted. A is -2, b is -4 plus k. Now, second part. State the range of f in terms of k. Okay, so again, the range of f is going to be given by the y-coordinate of the vertex. Is either bigger than that or smaller than that, depending on the coefficient of x squared. In this case, it's positive, so you have a positive parabola, which means that the y-coordinate of the vertex is going to be its minimum point, the minimum point of the range. Okay, so this is an upright parabola, so the minimum value of y is the y-coordinate of the vertex. Now that you have this written in complete square form, you know that the vertex will have coordinates, the negative of this 2, and that stuff, k minus 4, right? You want the range in terms of k, so this is it. The range is going to be bigger or equal to k minus 4. Where am I? Here. State the smallest value of p for which f is 1, 1. We already answered this in the previous question. The smallest value of p for which is 1, 1 is going to be this one. This is what you have. So the parabola is something like this. It's a 1, 1 parabola only either for values of x that are smaller than the x-coordinate of the vertex or higher or bigger than the x-coordinate of the vertex. All right? It's only going to be 1, 1 for this part or for that part. We wrote a more extensive answer in the previous question, I think. Or not. No, it's in the next one. You have a more extensive answer on the next one. All right, but for this to be 1, 1, right now, for example, if you take this value of y, whatever it is, you'll have this value of x and also that value of x. Okay, so you have two different values of x for the same value of y. All right, so it's not 1, 1, it's 1, 2. Okay, but if you restrain the parabola to either the left-hand side of this line of symmetry that passes through the vertex or the right-hand side of it, then you won't have that problem anymore, and it's going to be 1, 1. All right, so this case, you wanted the smallest possible value of p for which is 1, 1. The smallest possible means that they are picking this side over here, and v is going to be the smallest possible value of it. Anyway, in this kind of questions, the answer is always the same, is the x-coordinate of the vertex. You should understand the reason why, but the standardized answer for this type of question is x equals the x-coordinate of the vertex, 2 in this case. Now, for the value of p found in here, find expression for the inverse and state the domain of the inverse, giving your answers in terms of k. So now it's just a matter of solving the equation y equals the parabola. Again, this should be written in a complete square form, which it is right now. So solve it for x, and you have the same old problem, either picking the plus or the minus that we will always have in these cases. But since x is bigger or equal to 2, this only happens if you pick the plus, right? You already have the 2 over here. If you want bigger or equal to this, you'll have equal to it when all this stuff is 0. When this stuff is not 0, you need to add it, okay? So you remove the negative, and the final answer is this. What is the domain? The domain of the inverse, right? The domain of the inverse is the range of the original. And the range of the original you already found a little while ago. So you just plug it here again. Next question is this question over here. This is question 11 from October, November 2007. So you have a function defined by this is a quadratic again. First, express in the form, the quadratic in a form a x plus b squared plus b squared plus c, where a, b, and c are constants. Then state a range of f and explain why f does not have an inverse. You'll see a trend over here, right? So to have this completed square form, you should always factorize the coefficient of x squared, 2 in this case. All right. So, but I'm just factorizing this part of the function, not 11. Okay. So I have 2 open brackets x squared minus 4x plus 11. And then I can continue the completed square form on this section over here. So I'll have x minus half of that, sorry, x and then half of that, which is minus 2, close brackets, square, do minus 2 squared, that's 4, so remove it, minus 4, close brackets, and I just add that 11 over there. Now I expand these brackets, so this is going to be 2, open brackets, x minus 2, close brackets, square, minus 8 plus 11, which is plus 3. Okay, so I found the values of a, b, and c as being 2, minus 2, 3. So the range of f, you should know already. You always look at the y-coordinate of the vertex, which is 3 in this case. And then you look at the coefficient of x squared, just to check if it is positive or negative. It's positive, so you have a parabola like this. So this is going to be the y equals 3 is going to be the minimum value of y, right? So the range is going to be everything that starts from 3 up. So y bigger or equal to 3. Then explain why f does not have an inverse. Again, it is a parabola. So it's going to be, because it is a parabola, defined for all values of x, which means that all but one value of f, which is its vertex, will be 2, 1, which would yield a 1, 2 inverse, which is impossible. Okay, for all other values of the function that is not the vertex, you'll have 2 values of y, sorry, 2 values of x for 1 value of y, meaning that it won't be a 1, 1 as required for you to do the inverse. Then the function g is defined by the same expression as above, but now x smaller or equal to a, where a is a constant. State the largest value of a for which g has an inverse. You already know that the answer for this would be the x coordinate of the vertex. Just for you to know, they want the largest. So basically, I told you before that you will have a more thorough explanation, and here it is. A parabola can only have an inverse if we restrain the domain to one side of its symmetry line, or a section of it, okay? This means that the x coordinate of the vertex will either be the highest possible value of x, if we pick the left-hand side, or the smallest possible value of x if we pick the right-hand side. Okay? In any case, the answer is the x coordinate of x of the vertex. Let me just check one thing to see. State the largest value of a. Okay. The largest value of a would be a equals 2. I actually put here the domain, but the technical answer should be a equals 2, which I'm going to write. Well, I can write it right now. So let me just erase this, and I'll just write a equals 2. Last sub-question is for you to, when a has this value, obtain an expression in terms of x for the inverse and state the range of the inverse. Same stuff again, equal y to the completed square form, solve it for x. Eventually, you have to pick between the plus and the minus. Look at the restraint, and the restraint is x must be smaller or equal to 2. And this only happens if we pick here the minus. You already have 2 over here. For you to get something smaller than that, you have to subtract something else, right? So the expression is going to be this one. Write it in the correct form. And then I didn't write that yet, but it asks here for you to get the range of the inverse, and the range of the inverse is the domain of the original. What is the domain of the original? Is x is, let me just see one thing again, the largest value of a for which g has an inverse, the largest value of a. So if there is a largest value of a, they pick this side. So x is smaller or equal to 2. Okay, so that's your answer for this one. So again, the range of the inverse is the domain of the original. So y needs to be smaller or equal to 2. Let me just underline that. And this would be it.